Hello students, in this video we will see what is random variate and what are the techniques for random variate generation. So a random variate is a particular outcome of a random variable. It is a variable generated from uniformly distributed pseudo-random numbers. Depending on how they are generated, a random variate can be uniformly or non-uniformly distributed, and random variates are frequently used as input to simulation models. So the techniques used to generate random variates are inverse transformation technique and acceptance rejections technique. So the first one is inverse transform technique. In inverse transform technique, we have different samples. We can have different samples from exponential distribution, uniform distribution, Weibull distribution, empirical distribution, triangle distribution. So out of all these things, I think the only new one which you are going to learn is empirical distribution, because exponential, uniform, Weibull and triangle distributions already you have seen in module 2. So I will be dealing only with the fourth one, that is empirical distribution, which is empirical continuous distribution. So if the model builder is unable to find a theoretical distribution that is either exponential or uniform or triangle or Weibull, whatever, then that provides a good model for input data, then it may be necessary to use an empirical distribution of data. So one possibility is to simplify, resample the observed data itself. So what are the different steps we have in empirical continuous distribution technique is the step 1, arrange empirical data in ascending order. Second step, tabulate frequency and cumulative frequency. Step 3, assume the value of cumulative frequency as a function of empirical data. Then fourth step, find out what is x and ai. So x is nothing but inverse of r, which is nothing but x of I minus 1 plus a of I into r minus I minus 1 divided by n, for r between I minus 1 divided by n and I by n. So similarly, slope ai, according to this one, we can calculate slope ai as xi minus x of I minus 1 divided by 1 minus n. So let's see one example. 5 observations of fire crew response time in minutes to incoming alarms are given below. 2.76, 1.83, 0.80, 1.45, 1.24. Generate the random variates from the response time distribution using empirical continuous distribution, given the random number as 0.71. So the first step is group all the empirical data in the sorted in ascending order. So 0.80, 1.24, 1.45, 1.83, 2.76. So we will just tabulate few things here. Since there are 5 numbers here, I will be starting from 1 and to 5 here. Then interval between 0 and 0.8. So that is the interval for the first one. Then next one between 0.8 to 1.24. Then third one is between 1.24 to 1.45. Similarly between 1.45 to 1.83. Then between 1.83 to 2.76. So the difference between xi and x of I minus 1 will be 0.8 minus 0, 1.24 minus 0.8. One second, I'll just take the spotlight. Yeah, 0.8 minus 0.0, then 1.24 minus 0.8, 1.45 minus 1.24, 1.83 minus 1.45, 2.76 minus 1.83. So we will get xi minus xi minus 1 we have got now. Now frequency will be 1 by n, that is 1 by 5, n is 5. So throughout the frequency will be remaining as 0.2. Then cumulative frequency, either you can calculate it as I by n, or you can calculate cumulative, that is 0.2 will be the first one, second one will be 0.2 plus 0.2, 0.4, 0.2 plus 0.4, 0.6. So you know how to calculate this. Then slope will be calculated as xi minus xi minus 1 divided by p. So this value minus p. So 0.8 divided by 0.24, 0.44 divided by 0.2, then 0.21 by 0.2, 0.38 by 0.2, 0.93 by 0.2. So we will get the slope like this. Okay, next one, we will go to the next slide. So here we have just now calculated all those values, that is slope values. Now we know what are the random numbers as well, and these are the empirical data, and the random number given is 0.71. So first let us plot on the graph what are all the empirical data. So 0.80, so 0.80, 0.80, which is on the x-axis here. So 0.80, the next one is 1.24, next one is 1.45, 1.83, then 2.76. So we have got all the empirical data. So we will just join them, and then we will see the random number is 0.71, which is lying in between, let's say between 0.6 and 0.8. Okay, and the corresponding vertical line we will draw, which will give us x1 value, that is 1.66. Okay, so this is graphically we have done. So manually if you wanted to do, it is the random number 0.71 is lying in between between 0.6 and zero point 0.8, which is in the fourth interval. So first interval, second interval, third interval, fourth interval. So I becomes 4. Are you understanding? So x1 will be x of I minus 1 plus a of I into r1 minus I minus 1 divided by n according to the formula. So x1 will be, I has become 4. So just calculate, substitute the values, and if when you calculate, you will get it as 1.66.